Hey guys, welcome to Code World, and today we will be going over Leetcode number 15, threesome. So this problem is pretty similar to two other problems I've solved on my channel, which are twosome 1 and twosome 2, and we'll be combining concepts of both of those problems in order to reach the most optimal solution for this one. So in this problem, we are given a one-dimensional integer array of numbers, and what we want to do is return all of the triplets of this array such that their sum is equal to 0. And our solution cannot contain any duplicate triplets. So we have an example down here. We have an integer array called nums comprised of these numbers. And we see the output for this example contains two triplets. So our output is going to be a two-dimensional array. And each of these triplets satisfies the condition in which the numbers, when summed, equal to 0. So we know that -1 plus -1 plus 2 is equal to 0, so we add that as one of our triplets. And we also know that -1 plus 0 plus 1 is equal to 0, so we add that as our other triplet. Okay, so we're here in Excalidraw, and I will be showing you both possible solutions to this problem. First, a more brute force solution, and then I will show you how to optimize it to reach an n-squared solution. So the brute force solution involves finding every combination of triplets possible in the array, and then checking to see if this combination of triplets, when summed together, equals to the target, which is 0. This solution is going to be an n-cubed solution, and I will explain why. So the algorithm for this n-cubed solution involves having three for loops. One outer for loop, which will keep a pointer to a number, so we will initialize this to be the first number. Then we have a second for loop for a second pointer to another number, which we will have 7. And then the inner for loop will go through the remainder of the numbers in the array. So we'll have -8, 10, and -5. And what we'll be doing in this algorithm is that we are going to be summing these numbers up in each triplet. So we have -2 plus 7 plus -8, and we'll check to see if it is equal to 0. And in this case, it is not equal to 0. So what we will do is we will move on, and our next triplet is -2, 7, 10. So we will do the same thing. We will have -2 plus 7 plus 10. And again, we see that it is not equal to 0. And so we would continue this for every triplet. We then have -2 plus 7 plus -5, and we see that this is equal to 0. And so this will be one of our triplets, right? So after this, what we would do is we would move our second pointer to the next number, right? Our first pointer would remain at the first number. And then we would check as our third number the remainder of the numbers in the array. And finally, we would have another loop where we keep our red pointer here, our green pointer would move on to the 10, and then our inner for loop would just have this last number. At this point, we would need to move our outer pointer to the next number and restart. And this would allow us to find every triplet possible. Now, here is the code in Python for this first algorithm. As we can see, it would involve three for loops, an outer for loop, which goes from 0 to the length of numbers -2, a second for loop, which goes from I plus 1 to the length of numbers -1, and a third for loop for the remainder of the elements in each iteration. And because of these three for loops, it is an n-cubed runtime solution. And in each time, what we'd do is we'd see if the numbers sum to 0, and if they do, we would append the triplet to our result. Now, we would also need additional checks and data structures to make sure we aren't adding any duplicate triplets, but this is just a summary of the code, which I wanted to show you guys to explain why it would be an n-cubed solution. Now, in order to improve this runtime to reach the optimal solution, what we would need to do, first of all, is realize that we could take advantage of sorting these numbers, just like we did in twosome 2. So we're going to start off by sorting these elements in our array, and we know that a sort will take n log n runtime complexity. This will not affect our runtime complexity overall because our optimal solution will be n squared, so it is okay to sort in this case. So we know that -8 would be smallest, then we'd have -5, -2, 7, and 10. Then at this point, what we'd need is just one singular pointer, which we would start from the first number, and then we could have two other pointers, which is left and right pointer. And just like in 2sum2, we would take advantage of the fact that these numbers are sorted in ascending order in order to move these left and right pointers accordingly, right? So we would have our first check, and we would check to see -8 plus -5 plus 10, and we see that that would be equal to -3, which is smaller than 0. Okay, so in this case, because we have a sum which is smaller than 0, we know that we need to increase our sum. And we can take advantage of the fact that our numbers are sorted in increasing order. So because our sum is smaller than 0, we need a bigger sum. So what we would do is we would move our left pointer towards the right in order to increase our current sum. Now we can recompute a sum to make a check, and we can now check and see if our sum is equal to 0. So we have -8 plus -2 plus 10, and we see that that is equal to 0. So a triplet has been found. Because a triplet has been found, we can add these three numbers to our result, and then we can continue on with our solution, with our finding our solutions, right? So we can now move our left pointer again to the right by 1. And we'd recompute the sum, we would see that it is not equal to 0. And then at that point, when moving our pointer, our left and right pointers would cross, and we would be done with this inner while loop. So at this point, we can move our red pointer to the next number and repeat with the same algorithm. So we would move our red pointer here to the -5. We're then considering the -8. And then again, we have our left pointer at -2 and our right pointer at 10. So again, here we can compute a sum, and we would see that -5 plus -2 plus 7 plus 10 this time is equal to +3, which is greater than 0. So in this case instead, since we have a sum which is greater than 0, we want to decrease our sum, and we know our numbers are sorted in increasing order, so all we have to do is move our right pointer to the left. So having moved our right pointer to the left, what we would do is we would recompute the sum, and we would see that this time, when adding -5 to -2 to 7, we get 0. So a triplet has been found again, and we would continue this algorithm to finish all of our checks. However, in this case, we do not have 3 for loops in order to run this algorithm. We just have one outer for loop, which is represented by the red dot, to take into consideration the first number, and then we have an inner while loop with 2 pointers, left and right pointers, which will only traverse the array once. And because of this, we have an outer for loop and an inner while loop. This improves our runtime to an O of n squared time complexity, which is a great improvement over our previous solution. So this one is going to be O of n squared. So now we can go back to Leetcode and write up our solution. Okay, so we're back here in Leetcode and we're ready to write up our solution. So again, what we said is that first of all, we are going to start off by sorting the nums array. And we know that this is going to take an n log n runtime complexity just to sort. But that will not affect our overall runtime complexity, which we know will be n squared, which is greater than n log n anyways. And afterwards, what we're going to do is we're going to have our array, say, for example, -2, after having sorted it, actually would be -8, -5, -2, 7, 10. And we know our target is equal to 0. And what we would have is we would have initially our first pointer start at the first number. We would have a left pointer and a right pointer. And we would run an external for loop and an internal for loop using this idea of having an I pointer, an L pointer, and a right pointer, and taking advantage of the sorted array in ascending order. So we're going to start off by saying nums.sort, which is a Python method in order to sort the array and takes n log n time. And we're going to prepare our resulting array, which we know is going to be in a two-dimensional array. Then we can say for I in range from 0 to the length of nums -2 and in increments of 1, what we're going to do is have two pointers, right? We're going to have our left pointer, which is going to be equal to I plus 1, and we're going to have a right pointer, which is going to be equal to length of nums -1. And we're going to have an internal for loop, as we said, and we're going to continue this for loop until the left and right pointer do not cross. And we're going to calculate our sum. So our sum is going to be equal to nums of I, nums of L, plus nums of R. And then we're going to check to see the different conditions of whether our sum is smaller, equal, or greater than 0. So if sum is smaller than 0, what we wanted to do is increment our left pointer to achieve a larger sum. Else if our sum is greater than 0, we wanted to decrement our right pointer to achieve a smaller sum. And finally, if our sum is equal to 0, then we want to append our current solution. So we're going to append nums of I, nums of L, nums of R as a triplet. And then we can continue our algorithm by incrementing our left pointer. So you could also do this by decrementing the right pointer. You can decide whichever pointer to move in that case. Now, another thing we needed to make sure is that we do not have any duplicate triplets in our solution. So in our for loop, after starting each new iteration, what we want to check is that as long as I is greater than 0, and nums of I is equal to nums of I minus 1, meaning that the two subsequent numbers are the same, in this case, what we want to do is just continue on to the next iteration because we do not want to have duplicate triplets. So if I moves from one number to the next number being the same, we can just skip that iteration. And similarly, in our while loop, after finding a solution here and appending it, and moving our pointer, we can say that while left is still smaller than the right pointer, so they do not cross, and nums of L is equal to nums of L minus 1, meaning that we have moved the left pointer and it points still to a number which is identical to the precedent. What we can do in this case is increment our pointer again. Afterwards, what we can just do is return our resulting array. So let's check to make sure that this code runs. Okay, so I had a typo here. When decrementing the right pointer, we got to make sure we are decrementing by 1. I put 0 here by accident. And we should make sure our return statement is outside the for loop. So I'm going to rerun this again. And we see it's accepted. Let's submit. And it works. So thank you so much for watching this video. I hope you found it helpful. If you liked it, please like and subscribe to my channel. And I'll see you on the next one.